What I know about electronics, you could write on the back of the average postage stamp. Actually, probably not the average one, a particularly small postage stamp. I'm certainly no professional when it comes to electronics, as you'll have seen from my other videos, but I do know what the basics are. I know what a capacitor does, I know what a resistor does, transistors, and so on. I know what they do in principle. What I don't understand is how they work together, generally. And although I watch a lot of videos on YouTube, for example, I watch Dave Jones's EEV blog and Mike Harrison from Mike's Electrical Stuff, and guys like that, guys that have been doing this their professional lives. It fascinates me, but I'm never going to be able to understand electronics anything like as well as they do. So that's why I kind of stick to the kits, and I enjoy soldering, and I think it's because my professional career has got nothing to do with making things, it's got nothing to do with construction. It's very, very office based, and to be able to actually create something is something that I yearn to do, and therefore I turn to it as a hobby. Now, where is all this leading to? Well, one of the things that is quite clear is that if you've got something that isn't working or something that needs analysing, the professionals use oscilloscopes. And oscilloscopes, to me, seem to be pretty complicated pieces of kit. Trying to understand the sine waves and the square waves and the timing between the wave patterns and all the rest of it that you can understand by using an oscilloscope is a bit of a mystery to me. So it seems to me that as a novice I need to get my hands on an oscilloscope. Now, I'm certainly not going to be spending hundreds of pounds on one, so I decided to go for, yes of course, a Banggood kit. And this is a JYETech DSO138 oscilloscope kit, as you can see here. Let's open it up and have a look. Obviously it's a DIY build. Now, I got a feeling that the surface mount components for this kit are already installed. I don't know that for certain. I think there's some that they are and some that there aren't. We have a bag of components there. Looks like we've got a bunch of capacitors or resistors in there, surface mount resistors by looks of things. I don't know. I told you I don't know what I'm doing. We have the probes for the oscilloscope with a BNC connector. We have the main board, and yes, we have a surface mount component already installed, which is, if I bring up to my very poor eyesight, is STM32, whatever that is. But the point is that the tricky component has already been installed. Now, I have to be honest, I probably would be able to solder that, but that is a particularly tiny solder job, I would have thought. So anyway, so that's that. Components, main board, all straightforward so far. We've got a parts list. We have got how to use the oscilloscope. No point in looking at that until it's built. And we have a user manual, which I believe is actually the instructions on how to build it. And as you go through the kit, you tick off all the different components that you've actually used so that you know where you are. Now, this kit is actually very nicely put together. We've got a good quality manual here with colour photographs and very, very straightforward instructions which go onto the back. We have a troubleshooting guide here as well, which I dare say I shall probably need, because I'll inadvertently build it incorrectly, I should imagine, at some point. But there we go. So that's really good. Now, this kit, by the way, wasn't a lot of money. It was about 15 UK pounds, and I don't know what that would be in dollars. I would imagine something like 18 to 20, probably more like 18. It's not a lot of money for what it is, in my view. So the other component that I'm trying to open up here is the display, the LCD, which is a colour display. This will only be a single channel oscilloscope. I can't seem to open this for some bizarre reason. There we go, let's get this out and have a look. It's all stuck on there, there we go. And that's the LCD display. 2.4 inch TFT LCD, so that's a colour display. And obviously that will need to all be soldered up. Now as you go through the construction of this kit, I think there are test points, so it's points along the way. They say check the voltage here, there and everywhere. Could be wrong about that, but I have seen other people building this kit, or certainly kits like it, where that has had to take place, which is no bad idea, because it kind of makes sense. There you go. Number 20 there is test signal ring. Well, it looks like you're having to bridge a couple of jumper points there for test purposes, but at any rate, yeah, so we've got a 9-volt power supply. Now the power supply, as I say, just said there is 9 volts. There was a power supply that you could buy for it, which I did get, but it only cost £2, and it feels feather light, and I did actually open it, and again, let's open it up. Now again, understanding electronics is one thing, and running things off little batteries, and particularly button cell batteries like the clocks that I've been making is pretty safe. You're not going to blow anybody up by doing that. So let's open this up. It's being a bit troublesome. Now I have actually seen other people look at these, but I don't know. This is let me get better light on it. This is going to be taking 240 volt mains into these 2 little wires here, into a fairly straightforward board, which seems to be held together with bits of tape around the transformer there, and I don't know whether that's any good. I just look at it and I feel, you've got look at all these pins. Wouldn't you want to cut those short? You've got mains voltage in this damn thing, and that just looks iffy, and it doesn't sit in the case properly. It's sort of wedged in there by virtue of this block of rubber which has been stuck onto the board and then shoved into the case. I don't know, to me, I don't really particularly want to use that. I think that's iffy. So what I have got is a 9-volt power supply, which was at one time used for a mobile phone. I think it's got a different connector on it to this one, but that doesn't matter. I can just use this cable, assuming the cable's okay. That looks fairly substantial enough just to carry 9 volts, half an amp, something like that. But I'm not going to be using this power supply. That's silly. I don't like that at all. But that aside, the rest of the let's have a quick look at some of the components that come with the kit. They are here, and it's just now. I don't know why I'm really pouring all of this out now, because I'm bound to lose half of them. But there we go. We've got some spacers there, or mounts. That'll probably have something to do with the LCD at some point. Lots of surface mount capacitors or resistors, whatever they are. Resistors, I believe. What else? We've got plenty of ordinary traditional style resistors, some switches, electrolytic capacitors. The point being is that all of these components, of which there are many, are through hole, which makes them very easy. What's that? Oh, it's just another connector, jumper pin type connector. Well, not jumper pin, but something to plug probably the LCD to the main board when it's built up. Power jack, which takes the old 9 volts, which is fine, and the BNC connector, which is all metal, which is a good thing, I believe. And that pin obviously goes into the motherboard to collect the signal. And as I say, the probe is just BNC to a couple of crocodile clips. But again, it's, you know, fair enough. So all of this together is hopefully a reasonably straightforward build. Soldering these components on is going to be straightforward. There's a push to make button there as well, look, a little one. And they're all the sorts of components that you'd see in the other builds that I've done. Now there's an interesting one. That's a trimming capacitor, I presume, or resistor. Now whether that needs to be set to a particular value or not, I don't know, but we'll work that out as we go through. What else do we have? Little ceramic capacitors. That looks like a diode there. And there we have it. It's there's a crystal. What's the value of that? Not really makes any difference, but there's an 8 megahertz crystal, I'm guessing. On that, I don't know if this is focusing or not. Yeah, all fairly straightforward stuff. Now, even if I do get this thing going, let's assume that I do, will I understand how to use it? Now, to be brutally honest, oscilloscopes, in my view, and I've never really used one before, but looking at the guys on YouTube that do use them, having rotary control knobs seems to be a fairly critical thing to have. And of course there aren't any rotary control knobs on this, it's just switches and push to make switches and all the rest of it. So I'm kind of suspecting it might be quite difficult to use. But even if that's the case, then knowing how to use it is probably equally as critical. So there we go, that's the starting point with this particular kit. We do have, let's just show you this. Again, I mean, I've never seen a kit from Banggood, and I've bought a few in my time, with such good quality instructions. They really are good. Nice quality paper even. But here we have a layout of the board and where all the components go, parts list, being very clear on the orientation of ICs, how to install the surface mount components, and it's all very clear. Hopefully it's correct as well. And more on the back, although that's is that the same thing, but one side's in Chinese and the other is in English, which is fine. Very good. I mean, the quality of it, it seems very good to me, particularly for the price. It wasn't a lot of money. Just to complement it, because one of the things it did strike me when buying this is that it doesn't come with a case as standard. It requires you to buy the case separately, which I have here, and in good old Banggood fashion, it's more complicated than the device itself, but you can see it's a typical acrylic covered in protective paper, nuts and bolts and all the rest of it. But that seems fairly critical to me, because it's going to be fairly delicate afterwards, and if somebody's going to be stabbing at the buttons with their finger all the time, then you probably need it held in a decent case to make sure it doesn't get busted along the way. Now, having said all of this, once it's built, and again assuming I haven't screwed it all up, you need something to test it with, to understand how it works. So the other thing I bought, and I think this is the right kit, I believe so, but there we go, that's a signal generator. Again, I haven't got a clue how to use this either, so everything's a learning curve for me here. No idea whatsoever. I will construct this one, and I guess what I will be able to do is, as the name suggests, generate a signal of a particular frequency, and if I know what the frequency is on this and I can measure it with the oscilloscope, then I can understand the relationship, or I can understand rather how the oscilloscope will work, how it measures a known value, and therefore that will help me learn to use the oscilloscope and perhaps pick up some ideas about how these electronical things work. That's the idea, at any rate. So it seemed a good idea to get the signal generator as well. I'm not going to pull that one apart because that will be for another video. So what I'm going to do is, bearing in mind that this video is banged on long enough already, I think rather than put you through the pain of, now actually just show you here, look, there we go, there you are, resistors. So here's the surface mount resistors, and on the back they printed the values very clearly, very straightforward. Again, you know, 10 out of 10 for the quality of this kit in terms of making it easier for idiots like me to be able to put together, which is great. So hopefully, provided I take my time, it should be okay. It's not going to be difficult. So, guess that's an inductor there, I would think. Yeah, I think making it is going to be straightforward. It's all through hole. The major SMD component is already installed. Thankfully, these little resistors, they won't pose any problems for soldering for me. You've seen me do these before if you watch my other videos, and also installing the through hole components. So what I should do is I shall make this up, and then once it's made up, I'll make a second video showing how it works, or not so much showing how it works, but perhaps showing me learning how it works. Perhaps we'll go through the instructions together on that come with it as to how to use it. And also, as I say, we've got the signal generator there to build up, and then we can put the two together at some point and see if we can get some signals, and see if we can measure the signals and see how accurate this thing is. I'm very conscious of the fact that the quality of the construction of this device will be quite critical to a degree, because I don't think, in terms of accuracy, with the greatest respect to the people who designed this, it's hardly going to be professional grade stuff by any stretch, but it's probably good enough to give you an indication of what's going on in a circuit, or what the output from that circuit is, just to give you a rough idea. And for somebody like me, who's not a professional, who's not going to be spending several £100s on a real oscilloscope, this is better than nought, and you get to build it, which is the fun bit, the bit I like. So there we have it. That is the JYETech and oscilloscope, and the model number again, which was on that plastic bag, wasn't it? Let's give you the details there again. It's the DSO138. Now if you go onto Banggood and just search for oscilloscope, that's probably the easiest way to find it. This isn't the only kit that is on Banggood that you can build. There are other variants, other types of oscilloscopes. I don't know, I just focused on this one. It looked good. I knew that I could get a case for it as well. I think there's other kits out there that come with the case as standard, and a few others that have rotary controls, which I rather suspect would have been a better option in some respects. But there we go, I've got this one. So there we have it. What I'm going to do now is I will build this kit up over the next few days or whatever, and I will upload the final, or a video of the final built item as soon as I possibly can. Time's at a premium at the moment. I just seem to have one thing after another to do, so it's been a while since I've uploaded a video even, so yeah, I will try and get to the construction of this beastie as soon as I possibly can, but it looks fairly straightforward. And I keep on seeing components, and I'm lifting it. That's an IC there. There's a little IC that I shall have to solder on as well. That shouldn't pose any problems. There's nothing here of any great concern at all. So there we have it. Transistor there. Another little IC. Oh no, that won't be an IC. That'll be a voltage regulator or something. Yeah, you see, I don't know what I'm doing, but we'll find out how badly I don't know what I'm doing by the time I've completed this. Until then, thank you very much for watching. I hope you enjoyed it, and we'll have a bit of fun with this one, I think. All the best, catch you again soon. Cheers.